learned so far? What did we learn so far?
Maxwell.
Previously in our class, yeah, you are right. The first, you learn Maxwell's equations. There are 4 equations connected to what you already knew. Those are the Cauchy's law and the Ampere's law, Faraday's law. Okay? This is 4 equations, and I try to explain these 4 equations through spatial vectors and vector identity, those operators, to explain those 4 equations. Then what else after we learn Maxwell equations? The second topic is boundary conditions. We learn from Maxwell equations only for one single material. If the E field or H field, if they are in one single material. But what happened if there are 2 different media? We will apply boundary condition in the later of the class, in the later of chapter 1. There are some topics related to if they have different materials. Okay, can anyone tell me about the boundary conditions? This is a bonus time. Do you want to try? Okay, anyone? What happened if there are 2 medias? I call medium 1 and medium 2. If the median has epsilon r equal epsilon r1 and mu r equal mu r1, and for media 2 it is epsilon r2 and mu r2. If that happened, there are 2 different medias. What can we obtain from the boundary condition? Nobody want to answer my question? Do you want to try? I'll give you probably 10 points each. Anyone want to try to explain what is the result of boundary condition? Maybe you can just give me a result. Try 10 points for the just participation. Score. After class, you need to understand what you learn, not just sit here. There's no part, there's no credit. You earn nothing if you don't know what you learn in the class. You need to. Do you want to try? Yeah, come on. Yeah, it's fine. At least you try, right? Yeah, come here and maybe you want to say something 10 points. Easy. You can take your book, it's fine. You just explain to everyone and they will show, I will tell you if that makes sense. Okay, you can write down. is one of that. But in what kind of condition? Can you more specific? One is 1 and 2. What's the direction? Yes, the electrical flux density in medium 1 is the same as the electrical flux density in medium 2. All of them? Or is there any condition? There are two conditions.
When they have the same direction.
Yeah, which direction? Which one? Choose one. Vertical or horizontal for these two? It's close. Yes. Yeah, D1 equal D2. Yes. Okay, this is correct. This is correct. And is there any condition like charge or source? Usually, we don't have a question talking about the charge. Sometimes we don't have that charge, but for this case, you can see that from the third equation of Maxwell's equation, right? Is that a third one? Okay, I can give you 10 points because it's a little bit difficult. Right? This comes from here. Right? Comes from here. What is this? Net. What is this? Charge density, right? And why don't you have this one? Because we assume there is no charge density. There is no charge on the boundary. It's charge free on the boundary, okay? So this is 0. And for this one, we use the integral form. We was regard this like there are two area, and the height of this shape, the height is go to 0. So there are two charges. So according to that, we will see, finally, we will know the direction of these two electrical flux density can be cancelled to each other, because to this surface, the direction is going to up, and for this surface, the direction is going to down. So you can use D1 minus D2 equals to 0, which means they are the same. So you are right. So this is one of the boundary condition. And also, very similar to D, B has the same result. Because the same equation equals to 0, right? So the same equation, the same result. This is one of the boundary condition. And what else? What happened if we consider this direction of E field and H field? 10 points also. Anyone want to try? Raise your hand. If I give you an answer, okay, come on, just, do you want to try more? Do you want to try? So what is the equation? For this direction, you obtain these two boundary conditions, right? This is for the direction perpendicular to is the same as the direction of the surface. But what happened for these two directions? What happened? Is there any answer? I want just a quick result from our last class. You know what we are supposed to learn. $10 points, man. Don't want to try? Easy answer. Do you want to try? Don't know? No? Yeah. I know you know because we just discussed. So what can you obtain from another boundary condition, another two equations? Yeah, that is very accurate. Okay, good. Can you just say something about that? Do you have any comment on that? That is one of the boundary conditions. Could you please, or you want to speak in Chinese? I will translate for Nat. It's okay if you can learn. It's okay. Any way you feel that is comfortable. I believe there are many people still don't know about it, so don't worry about it. Just say, I don't know. You are telling people the truth. In which direction? 2E field in these two directions can the difference of these two fields, the value of these two E field is minus the abstract to each other, you can get what's that? Okay, magnetic flux density. Okay, and how about the direction? What is the result of the direction? What is the direction of E field? And what is the direction of the magnetic flux density? The last question. Not exactly. You should use a general way to explain. Okay, I'm telling people that for these two equations, we have a relationship about the D in this field and in this field, okay? The direction is to the normal, perpendicular to the face, to this direction. But what about the direction in this direction? What about the vector, the E field and the H field in this direction? What about that? We use this equation. The result is 2 of this E field, the difference between these two, E2 and E1, close to the normal direction. So you will obtain MS is to this direction, perpendicular. Okay, I give you 7, okay? Because you have a good equation, but you didn't answer all my questions. Do you know what the question comes from? Why can't you answer my question? I don't know, maybe we will talk later. Okay, so that's all. That's what all I taught last week. Okay, that's all, everything. I tell you, I summarize. This week, what are we learning? What will we learn this week? Let me write down the Maxwell's equations again. Yes. Equals to minus J omega. You can try to remember with me. Okay. B minus M, right? Try to remember because they are important. Close E, so comparison is H equals, this is minus, so it's positive, J omega D plus J. Current density, magnetic density. Electrical flux density, magnetic flux density. What else? D equals to charge density. What? B. It's not hard, right? It's not difficult. If you do this every week, you will remember something. So, okay, my question is, so what is E field? Can anyone want to answer my question? What is E field? This is easy, right? If you don't raise your hand, means you just don't want any points. You don't want to pass this class. That's it. Just, yeah. What is E field? Electrical field, right? This is an easy question, so I won't give you too many points, but I will ask you a lot of questions after that. E is electrical field. What does it look like in math? That's my question. Yes. What is the function of E should looks like? If this is, okay, one more question. Yeah. If, okay, listen everyone, this is related to this question, okay? I try to explain this question that you need to write down. This is a quiz. If we try to explain this electrical field in our coordinate system in x, y, z axis. Okay, we try to do that. So how many directions of that? 3. What are they? Tell me. E, x, E, y, and E, z. All of the field can be separated in 3 directions, x, y, and z. Okay? No question. Can we write down Ex like there is a function x, y, z, and what is the direction of Ex? Is x hat. Right? This is a unit vector to the x direction. So this is this one. And tell me what else for this and this two terms. E, y. I call this is the general form because I can use this to all of the E field because they are very general. Okay? My next question is, so far you earned 5 points. I will see how far you can go, okay? What is this? E, x, y, z. This is a function, right? You have some variables, functions of x and y and z, right? So what is this looks like? Is that like cos x squared, or maybe x square root of x, or maybe what is the form of this? Yeah, I know. That is what we already knew there, right? 3 variables. But there are too many guesses. You can guess, what is that? How can you know what is that? If you don't know what is the structure in math, you cannot calculate. You cannot start. You want to guess the structure, right? For example, if you know there is a line x on the xy plane, there is a line on it. You guess y equals to ax plus b, right? This is a structure. You know the form of y looks like this one. What is the structure of Ex? If you know this is the equation, all the lines is the equation of this one. What you need to do is you put some value on it to obtain a equals to something and b equals to something, and you can obtain the result. You can know exactly what the line is, right? But